November 19, 1940, 8,000 feet above Portsmouth. The Heinkel 111 bombardier pressed his face against the cold glass, scanning the coastline below. 3 days earlier, German reconnaissance had photographed every crane, every warehouse, every foot of the L-shaped breakwater. He knew this target better than the streets of his own neighborhood, but tonight, the harbor had vanished. Where docks and warehouses should have formed sharp geometric patterns against the moonlit water, there was only an unbroken stretch of luminescent fog that seemed to flow upward, defying gravity itself. The navigator checked his instruments twice, then 3 times. Every calculation confirmed they were in the right position. Yet according to his eyes, Portsmouth simply didn't exist. Before we dive into this story of impossible deception, take a moment to like this video and subscribe to the channel. We're building a community of history enthusiasts from around the world, and we'd love to know where you're watching from. Drop your location in the comments below. Your support helps us bring these forgotten stories back to life, one meticulously researched episode at a time. The bombardier stared down at the glowing wall of mist. It wasn't behaving like any fog he'd ever seen. Natural fog dissipates irregularly, thins at the edges, responds to wind. This fog had sharp boundaries. It formed rectangular patterns. In one section, he could see clear down to the water. In another, the obscuration was absolute. His training manual had covered smoke screens, temporary nuisances that marked targets rather than concealing them. But this was something else entirely, a phenomenon his instructors had never mentioned. A wall that seemed to think. And in that moment, though he couldn't articulate why, he felt the first cold whisper of doubt that Germany might not win this war after all. The science of aerial bombardment in 1940 rested on a foundation of geometric certainty. German bomber crews trained for hundreds of hours to recognize targets from altitude, memorizing the shapes of harbors, the patterns of rail yards, the distinctive outlines of factory complexes. Their Nicobine and X-Juret radio navigation systems could guide them within 200 yards of any target in Britain. But that final 200 yards, the difference between hitting a specific dock gate or missing it by a quarter mile, required human eyes. A bombardier needed to see his target, identify distinctive features, calculate wind drift, and release ordnance at precisely the right moment. The entire methodology assumed one fundamental condition: visibility. Britain's coastal harbors were bleeding wounds in the nation's defense. Portsmouth, Plymouth, Southampton, Liverpool, Glasgow. These weren't just ports. They were the arteries through which flowed every ton of food, every rifle, every drop of fuel that kept Britain fighting. Portsmouth alone handled 40% of Royal Navy operations. Liverpool processed 75% of all merchant shipping supplying the war effort. Lose these harbors, and Britain would starve within 3 months. The mathematics were brutal and inescapable, yet defending them seemed impossible. Fighter Command couldn't maintain constant coverage over every port. Anti-aircraft guns were effective, but the Luftwaffe had learned to bomb from altitudes where flak was sporadic at best. The German raid on Coventry in November 1940 had demonstrated the terrible truth. Even with advance warning, even with every available fighter scrambled, a determined bombing campaign could level a city in a single night. 500 tons of bombs had fallen on Coventry. Over 4,000 homes destroyed. The medieval cathedral reduced to a shell. And Coventry wasn't even a primary naval target. Major Geoffrey Turner stood in the Portsmouth Harbor Master's office on a gray morning in August 1940, studying blueprints that most military planners had dismissed as theatrical nonsense. Turner wasn't a traditional military man. Before the war, he'd designed stage sets for West End productions, creating illusions that made audiences believe painted canvas was solid marble, that electric lights were flickering candles, that actors standing 20 feet apart were locked in intimate conversation. He understood something the generals didn't. The human eye doesn't see reality. It sees patterns, shapes, expectations. The blueprint showed positions for 84 smoke generators arranged in 7 groups around Portsmouth Harbor. Not a solid wall of smoke, which would simply mark the target like a bullseye. Instead, a carefully orchestrated pattern of obscuration that would break up the geometric shapes a bombardier needed to recognize. The L-shaped breakwater would disappear behind one curtain of smoke. The distinctive row of cranes along the eastern dock would vanish behind another. The gaps between smoke screens would show nothing useful. Open water, stretches of shoreline that looked like a dozen other stretches. From 8,000 feet, Portsmouth would still be visible, but it wouldn't be recognizable. Each Mark V smoke generator stood 6 feet tall, 3 feet wide, painted in dull gray that absorbed light. Inside, twin burner jets ignited a chemical mixture designated FM compound, white phosphorus dissolved in carbon disulfide. The mixture was viciously temperamental. White phosphorus ignited spontaneously in air at 34 degrees Celsius. Carbon disulfide was both explosive and toxic. Storage required underground bunkers with inert atmosphere systems. Transport required specially modified tanker lorries with explosion-resistant tanks. When ignited, each generator consumed 24 gallons of FM compound per 4-hour operation, producing dense white smoke that rose to 800 feet and spread horizontally for 200 yards. The compound smelled like sulfur and burnt matches. It clung to clothing and skin. Crews who worked with it developed chronic coughs and eye irritation. One technician at the Portsmouth installation had suffered chemical burns when a faulty seal allowed FM compound to leak onto his gloves. He'd watched in horror as his hand began to smoke, the phosphorus igniting from body heat alone. But the smoke it produced was extraordinary. Particles measuring 0.5 to 1.5 microns in diameter, small enough to remain suspended for hours, large enough to scatter visible light across the entire spectrum. From altitude, it looked like luminescent fog. Unnatural, but not obviously artificial. The system could be ignited in sections, creating the illusion of movement. Group 1 lights first, obscuring the harbor entrance. 5 minutes later, Group 3 ignites, hiding the eastern docks. Group 2 follows, then Group 5. From a bomber at 12,000 feet, it appears that the fog is flowing, shifting, alive. A bombardier tries to identify the target in a gap between smoke screens, but by the time he's calculated wind drift, that gap has closed, and another has opened 300 yards away, showing completely different terrain. The first full test came on September 7, 1940. Luftwaffe intelligence had identified Portsmouth as a priority target for a major raid. German reconnaissance flights had photographed the harbor twice in the preceding week. British intelligence knew the attack was coming. At 10:47 p.m., air raid sirens began their undulating wail across the city. In the reinforced bunker beneath the harbor master's office, Turner gave the order. Phone lines crackled with confirmation, as each generator group reported ready. At 10:53, the first generators ignited. Crews across the harbor heard the distinctive whoosh of FM compound igniting. Columns of white smoke began rising, catching moonlight and glowing like phosphorescent pillars. Within 8 minutes, smoke had achieved 45% obscuration of the harbor. By 12 minutes, 70%. At 15 minutes, critical features, the dry dock gates, the ammunition wharf, the fuel depot, had disappeared behind curtains of luminescent mist. The Heinkel Formation arrived at 11:19. From ground level, observers could hear the change in engine pitch as the bombers began their attack runs. Then confusion. Engines throttling up and down. Aircraft braking formation. The distinctive whistle of falling bombs, but scattered irregular. Not the concentrated pattern of a precision strike. When the all-clear sounded at 1:34 a.m., damage assessment teams fanned out across the harbor. They found 17 bomb craters. 14 had fallen in the water or on undeveloped shoreline. 2 had struck a residential area half a mile from the docks. 1 had damaged a warehouse storing paint supplies, non-critical materials that could be replaced within a week. The actual naval facilities, the dry docks and ammunition stores and fuel depots the Germans had photographed so carefully, were untouched. One captured Luftwaffe navigator, shot down 3 days later, described the experience during interrogation. His words were carefully recorded by British intelligence. Die wandernde Nebelwand, the walking fog wall. We could see the city burning. The fires gave excellent light. But the harbor itself, it was there, then not there. Our navigator identified the target 3 times during one approach and each identification pointed to a different location. We released ordnance based on dead reckoning, but without confidence. The effectiveness wasn't just in concealment. It was in the multiplication of doubt. Before smokescreens, a German bomber crew approached a target with methodical confidence. Radio navigation got them to the general area. Visual identification of distinctive features confirmed the precise target. Wind calculations were applied. Bombs released. Now every step was contaminated with uncertainty. Is that the harbor entrance? Or just a gap in the smoke showing random coastline? Is that crane one of the documented targets or a piece of unimportant machinery? Is the smoke concealing the target? Or is the target somewhere else entirely, and the smoke is just marking a decoy? But Turner's system had a second component that most military observers initially missed. Smoke screens solved the problem of recognition. But smoke itself was visible from high altitude, potentially marking target areas. The solution came from an even more theatrical principle: misdirection. If you can't hide what the audience is looking for, show them something more interesting. The mirror installations, designated QL systems in official documentation, used angled sheets of galvanized steel and polished aluminum, measuring 12 feet by 8 feet. They were positioned in curved arrangements 2 to 3 miles from actual harbor facilities, placed to catch moonlight and searchlight beams. The principle was elegant. Water reflects light in distinctive shimmer patterns. The Thames, Southampton water, the Clyde, these were massive reflective surfaces that told Luftwaffe navigators exactly where they were. Place reflective panels in patterns that mimicked harbor entrances or dock basins, and you create false light signatures that draw attention away from smoke-obscured real targets. Southampton's QL installation was particularly elaborate. Near Calshot Castle, 4 miles from the actual dock facilities, British crews constructed a false harbor entrance using 37 mirror panels, arranged in an L shape that, from 12,000 feet, perfectly mimicked the geometry of the real Southampton harbor entrance. Painted canvas screens suggested warehouse roofs. Carefully positioned lights created the illusion of dock activity. From altitude, especially during partial moon conditions, it was approximately 75% as convincing as the real thing. Not perfect. Perfect would have triggered suspicion. But good enough to create a moment of hesitation. Good enough that a bombardier might think, "There's the target," and commit to his bombing run before realizing the mistake. Good enough that accumulated over hundreds of sorties, it pulled German ordnance away from critical infrastructure and scattered it across empty coastline. The true test came in May 1941. Liverpool, Britain's most critical Atlantic port, handling 3/4 of all merchant shipping supplying the war effort. German intelligence knew Liverpool's importance. Luftwaffe planners committed to a sustained campaign. 8 consecutive nights of heavy bombing, Operation Merseyside, over 2,300 sorties, approximately 2,000 tons of high-explosive bombs, and uncounted thousands of incendiary devices. The explicit goal was to destroy Liverpool's dock facilities completely, severing Britain's Atlantic lifeline. Liverpool's smoke installation, Esiel in the designation system, was one of the most extensive in Britain. 112 generators arranged in 9 groups covering 7 miles of waterfront from Gladstone Dock in the north to Herculaneum Dock in the south. The system had been tested in drills but never under sustained multi-night attack. On the evening of May 1st, maintenance crews performed final checks on every generator. Underground bunkers held 30 days of FM compound. Phone lines were tested and retested. Everyone understood what was at stake. The first air raid warning sounded at 10:41 p.m. In the Central Command bunker, the order went out at 10:47. Within 6 minutes, the first generators ignited. By 11:05, smoke screens had achieved 70% obscuration of dock facilities. The bombers arrived in waves. KG-55, KG-27, KG-54. Pathfinder units from KG-100 tried to mark targets with incendiary bombs, creating visible reference points for following formations. But the smoke diffused the light, made distances impossible to judge, turned clear reference points into diffuse glows that could be anywhere. Liverpool's city center burned. Over 1,500 buildings destroyed across 8 nights of bombing. The Liverpool overhead railway was hit and sections collapsed. Residential areas suffered devastating casualties. Over 1,700 civilians killed. The human cost was staggering and real. But the docks themselves, the graving docks and deep water berths and cargo handling facilities, survived. Of 40 critical deep water berths, only 7 were temporarily unusable. The Gladstone Dock Graving Facility, capable of servicing battleships, remained operational throughout the entire Blitz. Post-raid analysis of bomb crater patterns showed massive dispersal. Rather than the tight concentration around dock gates and warehouses that characterized successful precision raids, the Liverpool bombs scattered across a 3-square-mile area. Notable concentrations appeared 1 to 2 miles north of actual facilities, exactly where QL mirror installations had created false water signatures. Flight Lieutenant Hans-Joachim Hermann, captured after being shot down over Liverpool on May 4th, reported during interrogation, "We could see the river clearly. The fires provided excellent illumination, but the docks themselves, they were there, then not there. The smoke appeared to move, creating gaps that closed again. We released ordnance based on best estimate but without confidence. Running these installations wasn't simple or cheap. A 4-hour operation of Liverpool's 112 generators required approximately 10,652 gallons of FM compound, weighing roughly 48 tons. The compound cost $4 per gallon in 1941, nearly $200 today. A single night of smokescreen operations cost over $40,000 in compound alone. Storage required specialized underground facilities. Production ran at 500,000 gallons annually between 1941 and 1944, manufactured at secret facilities in Ridwan, Wales. The total cost of the smokescreen program between 1940 and 1945 exceeded $12 million, equivalent to roughly $600 million today. Resources that could have built approximately 400 Spitfire fighters. Fighter Command repeatedly argued that smokescreen budgets should be redirected to aircraft production. The counter-argument came down to mathematics. A Spitfire could defend one location at a time for 90 minutes of fuel endurance. A smokescreen installation could defend a fixed location for 8 to 12 hours per night, night after night, regardless of weather conditions that grounded fighters. For static targets of critical importance, smokescreens provided coverage that fighters physically couldn't match. Each major installation employed 40 to 60 dedicated personnel. Chemical specialists trained to handle pyrophoric compounds. Ignition technicians who could sequence 100-plus generators in coordinated patterns. Wind observers who measured atmospheric conditions and predicted smoke behavior. Telephone operators who maintained communication networks. Maintenance crews who cleaned phosphorus residue from burner jets after every 4th operation. These weren't reassigned military personnel. They were specialists trained for months performing work that was simultaneously tedious and lethally dangerous. The fundamental question critics asked was simple. Did it actually work? Were German bombers really fooled by artificial fog and mirror tricks? Or were they simply dealing with difficult weather conditions and the inherent challenges of night bombing? The answer came from German records themselves. After the war, British researchers gained access to Luftwaffe operational reports and bombing assessments. A translated after-action report from KG-55, dated April 15, 1941, following a raid on Plymouth, stated, "Target obscured by unusual fog conditions despite clear weather forecast. Bombing conducted by Dead Reckoning with estimated 40% probability of target coverage. Recommend future operations prioritize clear visibility conditions." This wasn't a natural fog. Plymouth's smokescreen installation had achieved 82% obscuration within 20 minutes of the air raid warning. But German crews, trained to expect natural meteorological conditions, interpreted the artificial smoke as unfortunate weather rather than active defense. That misinterpretation was itself a tactical victory. If crews recognized smokescreens as defensive measures, they could orbit and wait for gaps. But if they believed they were facing natural fog, they released ordnance based on Dead Reckoning and hoped for the best. Post-war analysis conducted jointly by British and German researchers calculated that smoke coverage reduced successful target identification by 76% on average. The figure varied, 65% effectiveness during high wind conditions when smoke dispersed quickly, up to 88% effectiveness during calm weather with partial moon illumination, when QL mirror installations were most convincing. Installations around the 5 most critical harbors, Portsmouth, Plymouth, Liverpool, Glasgow, and Southampton, remained operational throughout the war with cumulative operational uptime exceeding 93%. The cost effectiveness was undeniable. $12 million invested in smokescreens defended assets worth $2.8 billion in current terms. For 6.6% of the combined air defense budget, Britain gained continuous protection that fighters and artillery couldn't provide. But there's another metric that matters more than money. Harbor facilities employed hundreds of thousands of civilians whose survival depended on defensive measures they couldn't control. Smoke screens reduced casualties in protected areas by an estimated 65%. By 1943, the program had evolved beyond simple concealment into strategic deception. Installations around Dover operated on elaborate schedules during Operation Fortitude South, suggesting intensive activity worth protecting. Meanwhile, actual D-Day assembly areas further west received minimal coverage. Luftwaffe analysts drew the logical conclusion: the obvious targets were in the east. Every generator lit sent a signal about what Britain considered valuable, shaping enemy targeting priorities through chemistry and optical illusion. Between 1940 and 1944, smokescreen installations operated during 3,200 Luftwaffe raids. Crews worked through thousands of nights, breathing phosphorus-tinged air, knowing one equipment failure could create an inferno. None of it was glamorous. None of it involved the kind of heroism that fills history books.